And once we found it, once we get to -3, okay, now we have to go down 1 unit, down. And why do we go down 1 unit? Well, because the -1 here is negative, right? Down 1 unit, right? So our height here from the x-axis, that's the second number. The -1, right? 1 unit from the x-axis. The -3, we're 3 units to the left from the origin, from the y-axis, that is. All right. Are there any questions so far? All right. Okay, so from here, this is just some more terminology. That's, again, in math, there is a lot of vocabulary, okay? I mean, maybe you wouldn't expect math to have a lot of vocabulary, but it does. So in an ordered pair AB, right, this is a point in the Cartesian plane. The first number, the A, we call that the x coordinate of the point. It's the x coordinate of the point. B, that second number, right? It's called the y coordinate of the point. The y coordinate. I've seen some people call A the first coordinate, B the second coordinate. I think I've seen people call, if I remember correctly, some people call A the, I don't know if I'm saying this word right, abscissa, and B the ordinate. But again, for the most part, people call A the x coordinate, B is the y coordinate. Now, 2 points here, okay? 2 points in the plane, they're equal by definition if their x coordinates are the same and their y coordinates are the same. Well, actually, I should say this, exactly when their x coordinates are the same and their y coordinates are the same. So 2 points in the Cartesian plane are called equal. They're said to be equal. And we write this. If their x coordinates are equal and if their y coordinates are equal. Visually, the 2 points are going to overlap when you plot them. They overlap. I mean, I know it's kind of a duh, but it does. Well, I guess maybe I shouldn't say that. But it is something I should point out. Note that, in fact, this implies the order matters. I mean, we kind of saw that here with 2 and 1. See, 1, 2, and 2, 1 are not the same point, right? They don't overlap each other. You can see their x coordinates are different and their y coordinates are different. Same thing over here with these 2 points, 2, 3, and 3, 2. They are not the same point. And again, this is what I was trying to say before. The x coordinate is how far it's a way of telling you how far you are horizontally from the y-axis, right? You move horizontally. I mean, you're locating it on the x-axis, whatever it is. But in essence, you're moving a certain distance from the y-axis. The y-coordinate also is height. I mean, from when we plotted those points just now, hopefully you saw that. Okay, here are some other examples. Let's do those. Okay. With -3, 0, okay? Right, so what do? We have to find -3 on the x-axis, right? Now, since it's negative, of course, we have to go to the left. We go 3 units to the left. Boom, we're at -3. Now, do we go up or down? Well, since the y-coordinate is 0, we're not moving at all. We are not moving up, and we're not moving down either. Okay? So 0, the y coordinate is 0. We don't move up or down at all. So we're good. What about this point, 2, -1? There it is. Okay, so how do we get to that? Well, here, okay, what do? We have to find 2 on the x-axis. We get there by moving 2 units to the right, and then we go 1 unit down. I mean, notice the way this is marked up. This is not 1 unit. This is half a unit. This is -0.5. So we go down here. Excuse me, down here. 2 units over, 1 unit down. Good. What about this point, -1, -1? So -1, we go 1 unit to the left. This is half a unit here. We locate -1 on the x-axis, in other words. And now we go 1 unit down, and we're here. This is -1, -1. Good. Okay. Okay, so are there any questions about this? Okay. This is something else I wanted to point out, and this is also, I thought, useful to know. If you have 2 different points, right, they have the same y coordinate exactly when they're on the same horizontal line. Okay, I'm trying to illustrate that here. As you can see, although let me see if I can fix that. The pattern's a little bit off. I might do it. Okay, I think that's a little bit better. There we go. Picture was a little, Picture was a little bit off, although I think it still might be, but hopefully you can still see what I'm trying to say, that 2 points have the same y coordinate exactly when they're on the same horizontal line. Their y coordinates are the same. I mean, you kind of would expect that from the way we're plotting points, right? You know, if they have the same y coordinate, you're going to move the same distance up or down. In other words, the 2 points will have the same height from the x-axis. That's what I'm trying to illustrate here. It might be a little bit off, but I think everyone can still see it though. Here, 2 points, they have the same x coordinate exactly when they're on the same vertical line. Okay, that's when they're on the same vertical line. Okay? So that's what's happening here. They're on the same vertical line. Okay? I mean, mostly because you can see that they're going to be the same distance, the same horizontal distance from the y-axis. Okay? So, I mean, you know, it takes a little visualization, but it's not terrible. I know over here, you can see the point here, the dot is a little bit lower than it should be, but hopefully you can still see what I'm trying to say. So, all right, so, okay. Now, if you remember, absolute value was used to find distance, right, between 2 numbers on the number line, right? Absolute value was used for that, right? Well, I mean, that's one of the things absolute value tells you, right? How far apart 2 numbers are. No, excuse me, how far apart a number is from 0. But basically, absolute value gives you some kind of distance on the number line. Well, there is a distance formula for 2 points in the Cartesian plane. We can find the distance between each other. Namely, if we let P, okay, be a point, I'm going to say it's this point, x sub 1, comma, y sub 1. These are the coordinates of it. This is the x coordinate, the y coordinate, P. Q, let's say, has these 2 coordinates. So Q is another point, x sub 2, comma, y 2. So these are 2 points in the Cartesian plane. Okay. I did put an illustration here. Now, P doesn't have to be over here and Q doesn't have to be over here, but it's still giving us the same idea. If we let D of P comma Q be the distance between the two, okay, then we can actually calculate that distance. It turns out to be this. The distance between point P and Q is this. It's calculated by this formula. You have x sub 1 minus x sub 2 squared, right? X sub 1 minus x sub 2 squared. Subtract the x coordinates and square the difference. And then you do the same thing with the y coordinates. You have y1 minus y2 squared. Okay? And you add those squares and take the square root of that. Okay? You add those squares and take the square root of that. Because we're squaring, it really doesn't matter the order in which you subtract the numbers. I mean, you have to subtract the x coordinates from each other, and you have to subtract the y coordinates from each other. But the order doesn't matter, even though it's subtraction. And again, that's because we're squaring. That's what that is.